Hello friends, welcome to our channel of in last video we have learned about how to develop a basic simulation with reference to simple models. In this series too, today we are going to learn about introduction to AVEVA steady state simulation and dynamics state simulation for the same example which we have learned in last lecture. So to create new simulation we go ahead with the process. Rest of the things like simulation building, we are not developing a new model, so we avoid the model writing in this lecture, and we have selected unit as SI unit. Okay, we can rename this as steady state. Steady state. Okay, to proceed with the process, we just develop some model with reference to the available models and we connect them here. So to remove these badges, we need to input some data. So input that data, we have to just add some parameters. Here we consider the fluid as a cooling water here based on the mass flow rate. Then we have to specify these boxes where tick mark is mentioned. That means that data needs to input by us kg per hour. Then the pressure we can consider it in is bar, so we can consider 3 bar gauge as a pressure. Then temperature of cooling water is 30 degrees Celsius. Rest of the things are same. Okay, so we close this. Then we need to draw in this control wall module. We have to just update the pressure drop across the wall. Rest of the things like wall data, linear operation, then the CV selection is actual for the steady state. And in steady state, we will get the selected CV for selected or calculated CV for the wall based on the pressure drop across the wall and the input parameter like flow and all this. For here, we consider the pressure drop is 0.5 bar. Okay, now we can get the CV selected or calculated CV is 26. So we can put here CV and we need pressure drop across the wall for the dynamic model, and this is the input pressure which we have given, and manual position of this opening can also be taken here so that we'll get idea about the its impact on the simulation. Okay, here until now our model is in solve stage. If you looks, all the tick boxes are green, that means our simulation is in solid stage. So we consider that input flow rate, we can rename it as feed. It can be renamed as a control wall, and it can be outlet. Okay, wall. Okay, so based on the outlet, we can select the flow rate Q based on meter cube per hour. Okay, that can be taken here. So now this in steady state, this model is solved. In steady state, we have input given the feed flow rate, and based on that delta P across the control wall, and we get the calculated CV for this particular. If we change the feed flow rate, I just change from 15,000 to 25,000, you will get the calculated CV. Earlier it was 26. Okay, and second input is the manual position of control wall, whether it is 100% open. One fraction means 100 percentage of opening, 100% open, or we can change to 50%, then it directly gives the calculated CV based on that. Okay, in steady state, I hope you got the clarity about the steady state simulation which we have performed here. Okay, we can also you can take its snapshot by here, like you can you have taken snapshot, then you can check the snapshots available here. You can rename it as steady state simulation. So you can take such a 50 snaps, so you can get back to any state during the simulation by simply clicking on here. You will get the number of snapshots. Okay, so it's before moving ahead for the dynamic state, we can change its position to 100% opening, and the flow rate is 15,000. Okay. If you check, this process is in steady state flow. This simulation is solved in the steady state. Now we moving ahead with the dynamic. So we need to consider dynamic modeling here. So in dynamic modeling, you will get uh, some unspecified inputs here. That means you will get the red badges at the control wall as well as the outlet. So unless and until this solve these badges, your simulation is not in steady state. And after this badges green, you can start the simulation from here running it. It shows the running of the simulation. Before moving forward, we can check the whatever input required in dynamic model. We can change the control wall CV, and based on that, you will get the flow rate. Uh, So for initially, we can consider 26 as it is. Okay, so and the pressure drop is also same, outlet pressure. So is solved in the dynamic state. Okay, so before moving to the, we can shift that with reference to like this. Okay, now we can check the trends in the running state. Before moving ahead, we can start the simulation. Now for the selected CV, our flow rate is 15,000 kg per hour. So if we change that CV from 26 to 45, then it will change the flow rate according to that selected CV. So you can check the graph or trends against control wall CV versus the flow rate. So you can check from here trends. You need to just drop down here, and before you have to select the parameters which you have to observe for this particular trends which we need to observe. So we can select the trends for the control wall CV versus the outlet flow rate, which okay. So the simulation is in running stage. So you can check the trends for the running simulation. Okay. So you can change the color of control wall CV to green and whatever color you want to. Okay, this is the graph of control wall CV and the flow rate versus time. So you can change the its axis also, or from opposite. So you can select the control wall CV to the right of the axis, and you can check the time grid 30-second or 40-second, whatever you want, 10 times span of 120 second. Instead of this, you can change to 150 seconds also. Okay, so now you will see the trends. You will observe the trends here. For here, you can check the trends of control wall. Flow rate was this is the flow rate versus the control wall CV. It's in steady state as we have fixed the both the values right now. So you can change the you can change you can park it here, and you can change the control wall CV from 45 to 18, and you will get the its trends. It drops the flow rate and the CV value. Okay, you can after we have changed the data, and you will get the flow rate versus CV here. Okay, for this much of CV, 17 value, 18 value, and you are getting the flow rate of 10 meter cube. You can check in the simulation state as well. Okay, so for this also we can change 70% opening. Also, you will get the differences here after 70% opening that drop down the flow rate from 10 meter cube to I think approx 7 meter cube. You can check the simulation in running stage here. Think you are getting the idea about this. Okay. So in this way you can check for the different cases. For here now we have considered the CV value 55. You will get the trend on the same time, and after certain time you can generate the Excel report from here also. Hope you all get the idea about how to develop a steady state and the dynamic state simulation. Okay, thank you. Bye bye. If you have any question, you can drop me a message in a comment section so that we can cover the your aspect or your query, try to resolve in the next session. Okay, thank you for now.